All right. So what if our function is in radical form? Okay. Or if we have a radical function where the index is 2. Um, Basically, this formula or this rule is derived from the power rule. We can transform square root of u as u raised to the power of 1/2, right? So we can use the power rule basically. Okay, so let's compare this with um, the result if we apply the power rule. Okay, so special case because the n is 1/2. So we can write again, no, u or square root of u as u raised to the power of 1/2. Okay, so let's say that would be our y. Okay, so using power rule, no, our n here is 1/2 and our u is u. Okay, so again, we're trying to derive this formula here, this equation here, no, from the D7 or the power rule. So n is 1/2 and the base is u. So using power rule, okay, we have y prime is equal to, so you copy the power or the exponent or the n, and then copy the base and then raise it to the n minus 1 and then multiplied by the derivative of the base. Okay, so let's continue. That's 1/2. Okay, 1/2 minus 1 is negative 1/2. So just copy the du dx. Then we can transform this exponent into a positive value if we apply no, the one of the laws of exponents. Now if we have x raised to the power of negative number, so we can write it as 1 over x raised to the power of positive n. All right. So we can write this therefore as 1 over u raised to the power of 1/2. Okay. And then multiplied by du over dx. And if we transform this back to radical form, so it's basically square root of u. So multiplied by 2 in the denominator. So we have 1 over square root or rather 2, no, square root of u times du over dx. Then we can put the du over dx on top. Okay, multiply du over dx with 1 in the numerator so that we can have the formula written no, above. Okay, so it's the same thing, du over dx over 2 square root of u. Okay, so again, we are deriving no, this power or this rule rather. Okay, so if you can see a square root of u, so you can just go with the derivative of u with respect to x directly and then just divide it by 2 square root of u or 2 times the given radical as short of a shortcut. Okay, so this is applying no, the power rule. Okay, so that you will no longer need to show no, these steps. So just follow the formula. Okay. So for example, so we have square root of 4x minus 81. Okay. So again, to reduce time in solving um, using power rule, so we just use D8. Okay. So from the formula above, okay, for a moment. So we need to get the derivative of the base and then divide it with 2 square root of u. square root of the given or radicand. So the one inside the radical is called the radicand. So our radicand or the u is 4x minus 81. Okay. So for the derivative, so you get the derivative of the u or 4x minus 81 and then divide it by 2 square root of u or 2 square root of 4x minus 81. Okay. So it's shorter na, no? And dili na tong power rule, you express it as kuan pagyud, no? 4x minus 81, quantity raised to the power of 1 half, and then apply power rule. So this is a special case, no, where n is 1 half. So you can just apply, no, the rule right away. So derivative of 4x minus 81 is 4. And then it's always a 2 here in the denominator beside the square root of u. Okay, so simplify. We have 4 divided by 2, so that's 2. And then over square root of 4x minus 81. Okay, so this is the y prime. So example number 2, we have our u equal to, it's a fraction, not 2 over x minus 8. So we need to use quotient rule here together with the special rule non D8. Okay, so get the derivative of the u. So derivative of 2 over x minus 8 and then all over 2 and then the given, no, square root of 2 over x minus 8. Okay, so derivative of 2 over x minus 8. So using power rule or yeah, using quotient rule, not power rule. Okay, so it's the denominator multiplied by the derivative, no, of the numerator, meaning derivative of 2, and then minus. Okay, so let me put this note here to the right side. So for the quotient rule, so after the first function multiplied by the derivative of the second function, so you copy, or rather the denominator multiplied by the numerator minus, okay, the numerator multiplied by the derivative of the denominator. Okay, and then all over. Okay, so let's transfer the equal sign below because the main fraction bar no, is between these two, the main numerator and denominator. So if we are going to have the over b squared pa for the quotient rule application, so x minus 8 na quantity squared. So we need pa to make another fraction line. So this is the main fraction line na separating this one, the derivative of 2 over x minus 8. And no need to get the derivative of these expressions because we simply copy them. No, there's no d over dx here. So just copy them. So this is the main fraction line or bar. It's not yet the final answer. So let's just put lang an equal sign, and put the y prime later na for the final answer. Pero you can still write the y prime if you want to. So we have, so later na lang na for the one, main fraction bar. So x minus 8 multiplied by the derivative of 2 is 0. Then minus 2 times the derivative of x minus 8 is 1 minus 0, no, or 1. And then all over the square of x minus 8. And then all over pag yun, 2 square root of 2 over x minus 8. So this is the main fraction bar. So let's continue. 0 for the first term minus 2. So that's 2 over the square of x minus 8. Okay, and then all over 2 square root of 2 over x minus 8. Okay, so we can cancel out the 2's here. Okay, take note there's still a 1 on top. Okay, then let's combine the x minus 8 here and the x minus 8 here. But we can combine them because they are both expressed as x minus 8. Okay, so we can separate the 2 and the x minus 8 no, inside the radical sign. So using one of the laws of radicals, we are having a radicand expressed as a fraction, so we can write it as square root of m over square root of n. Okay, so meaning we can write the copy set, no, the one on top, and then for the bottom, so we can write it as square root of 2 over square root of x minus 8. Then we have a complex fraction. No, we simplify a complex fraction by multiplying the reciprocal of the denominator with with the numerator. So this is the main numerator. So we copy it and then multiply it with the reciprocal of the denominator. So reciprocal of this is square root of x minus 8. So just interchange the numerator and denominator of this fraction. So we have square root of 2. And then we can express it as u to the power of n form where n is 1/2, no? So x minus 8 quantity raised to the power of 1/2 since it's square root man, no? So exponent is 1/2. And then just write this as square root of 2. So we can combine these two using laws of exponents. So if we have two expressions, okay, or if we have x raised to the power of m and then over x raised to the power of n, okay, they have the same base. So basically, this is division. So all we need to do is to subtract. Okay, copy the base and then subtract, no, the exponent. So exponent of the one on top in the numerator minus the exponent of the one in the denominator. So copy the common base. So the common base is x minus 8. Okay. And then there's an over square root of 2di. Okay, so this would be equal to 1/2, no, minus 2, and then all over square root of 2. So we have 1/2 minus 2, that's negative 1 and 1/2, or that's negative, no, 3/2 over square root of 2. And then for the final answer, so let's put back the x minus 8 at the bottom since it's a given, it's at the bottom. So if we transfer this in the denominator, so we have 1 na lang on the numerator. Yeah, square root of 2, and then x minus 8, raise it to a power of positive, no, 3 halves. So if this is already the final answer, then you put a y prime here, or dy over dx. Okay, so that's the first special formula related to the power rule. Okay, because there's another one. No, D9 is if the exponent is -1. Okay,